Okay, so today we're gonna go ahead and do 5.1 here, simplifying rational expressions. So we have two goals here: simplify each and state the excluded values. So I'm actually on each one of these. I'll state the excluded values. I wouldn't do that in red. And for that, what you're gonna want is we're just gonna say that the denominator cannot equal 0. That's the key part of that, okay? So if I do number 1 here, I'm just going to take that denominator, which is 16n squared, and I'm going to say that cannot equal 0. And now I need to solve it. So I'm going to divide by 16. So n squared cannot equal 0. That's what that equal sign crossed off means, it cannot equal. And if we square root both sides, it would just be n cannot equal 0. Okay, so that's that. Next up, we're going to go ahead and simplify here. So to simplify on these first two, it's pretty simple. So with the numbers here, we would just divide them by the biggest number that we think they can both divide by. I think that those can both divide by 4. So I'll go ahead and do that. And if I do that, I get 6/8. But then I notice I can actually divide by 2 again. So I'm going to go ahead and do that. And so I get, what would that be? 3/4. Now, it turns out I could have divided by 8 initially, but I didn't see that. That's okay. Just kind of, once I divided by 4, I noticed, okay, I'm not quite done yet. I can also divide by 2. So just kind of keep looking at it if you're not sure you got the biggest number possible, okay? All right, next up, we'll deal with the variables. We have n on top, n squared on bottom. I think of that as n to the first on top. And so we kind of used to do this kind of simplifying exponents here. So the way I think about that, the denominator has the bigger exponent, so it's going to kind of win the battle, and it wins by 1. So I'm just going to put n to the first power down there. So that would be my answer for the simplify, whereas this would be my answer for the state the excluded values, okay? Same idea on number 2. So I always start off by stating the excluded values. The reason we want to start off with that is sometimes when you reduce, some of the excluded values get eliminated, but that you shouldn't, they need to carry over is what I'm trying to say there. So that's why we want to do this first. So this one will also be a cannot equal 0. And I'll tell you, anytime there's no adding, or if there's a variable on bottom but there's no adding or subtracting, it will always be 0 as the excluded value. So now let's go ahead and simplify it. So with these both, we can divide by 10. And so that'll give me 10/7. And then for a to the third and a squared, the top has one more, so I'm going to put 1a up there. All right, next up here, number 3. So we'll start off here with our excluded values. So we're going to say the denominator cannot equal 0. Oh, that's 20 right there. So then I'll add the 20 over. So 2x cannot equal 20. Divide by 2. So x cannot equal 10. Okay, so now we will do the simplify. So on these ones now that we have adding or subtracting, we need to factor. And so factoring on number 3, I'm going to GCF a 2 out of the denominator. And you can see that's going to leave me with x minus 10 in here. The top is x minus 10 as well. I cannot factor that. And so what you're going to notice on most of these is once you factor, you're going to get kind of one parentheses that matches up top to bottom. And when that happens, you can actually cross those off. I know the top wasn't written in parentheses, but you might as well. It can be. It means the same thing. So then there's nothing. I know it's 2 left on bottom now. There's nothing left up top. When there's nothing left up top, you have to put a 1 up there. It's kind of a placeholder. So this one will just be 1/2. Okay, next up we'll do number 4. Very similar on this one. So I'll start off by finding the excluded value. By saying that the denominator cannot equal 0. So we'll subtract the 30 there. So 5p cannot equal -30. And then divide by 5. So p cannot equal -6. All right. Oh, I didn't box up this from my number 3 there. Okay, so now we're going to go ahead and do our simplifying. So same idea here. I'm going to GCF on bottom. So we can take out a 5, which leaves me with p plus 6. And that matches up with what's on top, so we can cancel those out, and I'm left with 1 on top again, and this time it's over 5. Okay, number 5 here, I'm going to start off by doing the denominator cannot equal 0. Now in this case, this is going to require me to factor, okay? So I'm going to have to do I was factoring before with the GCF, but now it's the diamond factor with the a times c up top and the b on bottom. So a is 1, c is -6. And then b is -1. So I have to think of two numbers that multiply to -6 and add to -1. So that's going to be -3 and +2. So I need to split up my middle term then, negative 3k plus 2k, according to those numbers. Now I'll just bring down my k squared here, and then my minus 6 over here. All right, now I'll put them into groups. And the first group I can take out a k, which leaves me with a k minus 3. And the second group I can take out a positive 2, which leaves me with k minus 3 again, which means k minus 3 times k plus 2 cannot equal 0. And so now that I'm factored, I can set each of these not equal to 0 individually. So if we add the 3, we would say k cannot equal 3. And if we subtract the 2, we would say k cannot equal negative 2. All right, so now, so that one has 2 excluded values, you can see. We need to state them both, okay? And now we need to simplify. So for this, we need to factor. The good news is we already factored. So I'm actually going to take my, my factored form right here, and that's going to be my new denominator. So I have it as k minus 3 times k plus 2. And you can see that the numerator, since it cannot factor, I can actually cancel that out. And I'm left with 1 as my placeholder up top, and all I have left on bottom is k minus 3. So very important here, you are allowed to kind of use your work from this piece to help you with this piece over here. It makes it a lot easier, okay? All right, so then next up, number 6. Let me move over here. So first of all, for the excluded values, this one is actually kind of a special case. There's no variable in the denominator, and therefore there's no excluded values, okay? So anytime that you have no variable in the denominator, that is no excluded values there. So just keep that in mind, okay? There's no x value that would make the denominator 0 because there's no x in the denominator, okay? So now I'll just move on to my simplifying. I need to factor out of the top here, so I'm trying to think, what can I divide 28 and 32 by? So I think it's a 4. That would give me 7x minus 8 over 36. And then I would just, and now that I have it factored out front, I have to divide those two by the same number, which would be 1. So I have 7x minus 8, sorry, would be 4. So I have a 1 times 7x minus 8 up front, up top. I'm not going to write the 1 there, but I'm dividing these by 4, so now the bottom would be 9. All right, next up we got number 7 here. So for this one, we'll start off our excluded values. We're going to say the denominator cannot equal 0. So if I subtract the 16, we have 2a cannot equal negative 16. Divide by 2, a cannot equal negative 8. So that's my excluded value there. I have to factor the numerator now. So I'm going to do a times c up top and b on bottom. So thinking of two numbers that multiply to 56 and add to 15. And so I think those numbers would be 8 and 7. So I need to rewrite that middle term. Well, I'm going to rewrite a squared, and then I'm going to split up the 15a as 8a and 7a, whatever order you want. Now I'm going to do my grouping here. So I'm going to take out an a, leaves me with a plus 7. I'm going to take out a positive 8, which leaves me with a plus 7 as well. And so we have, let me do this in blue here. Our numerator now in factored form is a plus 8 times a plus 7. And then the denominator here, I need to factor that as well. I can take out a 2 here, which gives me a plus 8 inside. That's nice because we see we have a matching parentheses. We can cancel those out. We get a plus 7 all over 2. All right, next up here, number 8. So I'm going to do the excluded value first. So we're going to take the denominator, and we're going to say that that cannot equal 0. We are going to have to factor this right now. We'll have to factor the numerator and denominator eventually. So this one will be an x. They'll both be an x, actually. So multiplying to negative 45 and adding to 4. That would have to be 9 and negative 5. So I'm going to split up that middle term, 9n minus 5n minus 45. And have the n squared here. So then we'll do our grouping. So I can take out an n here, which gives me n plus 9. I can take out a negative 5 here, which gives me n plus 9 as well. Remember, when you take out a negative, that's going to switch both signs. And then, so now my factored form is n minus 5 times n plus 9 cannot equal 0. All right, so now we can set those not equal to 0 individually. If you want to do a shortcut here and just say these are both be the opposites, so n cannot equal 5 and n cannot equal -9, I think that that's okay. So that is our factored form then. Or sorry, that's our excluded values. All right, and so now we'll factor the numerator. So I'm going to think of two numbers that multiply to -72 and add to 1. So that's going to be 9 and -8. So I'm going to rewrite that numerator as n squared plus 9n minus 8n minus 72. And then we'll go ahead and group that. So the first group I can take out an n, which gives me n plus 9. The second group I can take out a -8, which leaves me with n plus 9 as well. And so we got here. So we'll have n minus 8 times n plus 9 up top. On bottom, I have my factored form from back here, the n minus 5 times n plus 9. You can see we have our matching parentheses there cancel out, so we're left with our answer is n minus 8 over n minus 5. All right, last one here, we'll start off with our excluded values. So we're going to say that this did not, we'll skip number 9 first of all, but this last one here, we'll say the denominator cannot equal 0. I'm going to factor this one. You can't do an x thing on this one. It's just GCF. So I'm going to take a 9x squared out front. And that's going to give me k minus 1 on the inside. So this one, you can see we take out the 9. So there's no number in front. And then we had k to the third. We took out k squared. So there's just k left inside. This one, we took out the whole term. Whenever that happens, there's always a 1 left over. So then what we need to do is we need to say both of these, 9k squared cannot equal 0, and then k minus 1 cannot equal 0. For this one, we can use our shortcut, so it's just the opposite, so k cannot equal 1. This one, if I divide by 9, k squared cannot equal 0, not divide by k, excuse me. We would square root that, and so k can also not equal 0. So we do have two excluded values there, okay? All right, now the numerator, we need to do an x factoring, so we're going to think of two numbers that multiply to 6. And add to -7. And so that would be, let's see, that would be -6 and -1, right? Yep. Okay, so I'm going to rewrite that numerator, split up that middle term there according to my x, and now we will do our grouping. So group it up and then take out the k here, and that'll leave me with k minus 6. Over here, I'm going to take out a -1, and when you take out a -1, it changes the signs here to k minus 6. So my numerator there is going to be k minus 1 times k minus 6. And then the denominator, I'm going to steal the factored form from here, 9k squared times k minus 1. We see we have the matching parentheses top to bottom. So that's nice. We get to cancel something out. And there we go.